And now in this lecture we answer two questions. In the first question we find out the radius of this circle. In the second question we find out the area of this semicircle APQB. So we start with the first question. In the drawing we have a circle. This is line 7CP. This equals to 12 units in its length. This is line 7AP. This equals to 3 units in its length. This is line 7PB. This equals to 4 units in its length. This is angle CPB. This is equal to 60 degrees inside. Again, our task is to find out the radius of this circle. So first of all, it is given us the question that AB is a straight line. So if you focus on the upper side of the straight line AB at point P, here the sum of the angles must be equal to 180 degrees according to all three. So which angles we have at the upper side of the straight line? Which angles we have at the upper side of the straight line AB at point P? We have this angle, this is equal to 60 degrees in size, plus this missing angle, in total the sum of those two angles must be equal to 180 degrees according to all three. Therefore this missing angle must be equal to 120 degrees in size. In the next step, we join points C and B together by straight line. And we join points C and A together by straight line. By doing those constructions, we can do three triangles. This is the first green triangle APC. And also the white triangle CPB. And the third triangle is triangle ABC that consists of those two smaller triangles. So in the next step, we will implement the law of cosines on one of those three triangles. So please click here on the law of cosines. The law of cosines is true in any triangle. This is triangle ABC that could be any triangle. This is angle BAC, this is equal to 30 degrees in its size. This is side AB. This equals to 8 units in its length. This is side BC. This equals to 3 units in its length. This is side AC. This equals to 3 units in its length. This triangle ABC that could be any triangle according to the law of cosines, the following equation is true. C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Again, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. So in the first step, we will implement the law of cosines on this green triangle, triangle CAP. In the green triangle CAP, according to the law of cosines, we'll choose angle theta as this angle, angle CP8 is equal to 180 degrees in size. So according to the law of cosines, this grand triangle CP8, the following equation is true. CA squared equals to AP squared plus PC squared minus 2 times AP times PC times cosine 120 degrees. And again, in this grand triangle CAP according to the law of cosines. The following equation is true. CA square equals to AP square plus PC square minus 2 times AP times PC times cosine 120 degrees. CA is the missing side, so we leave this it is, so it is CA square equals to AP square. AP is 3, therefore AP square is 3 squared, that is 9 plus CP square. CP is equal to 12, therefore CP square is 12 squared, that is 144. Minus 2 times AP, that is 3, times PC, that is 12, times cosine 120 degrees. Cosine 120 degrees is equal to minus 1 half. So total, we should find out that according to the law of cosines, in the real CAP, the following equation is true. CA square equals to 9 plus 144. 9 plus 144 is 153. Here we have minus times minus is plus, so this expression is a positive expression. Here we have also 2 in the numerator, 2 in the denominator, so 2 will get cancelled. So this expression in total equals to 3 times 12, that is 36, plus 36. This is a positive expression. So in total we should find out that CA square equals to 153 plus 36. 133 plus 36 is 189. So in total we found out that CA square equals to 189. So here we take a root out of this equation. We get that CA equals to the square root of 189 units in its length. So if you found out that the length of side CA is equal to the square root of 189 units, now CA equals to the square root of 189 units, and CA square equals to 189. Likewise, we will implement the law of cosines on this right triangle, triangle CPB. We will choose angle theta as this angle is theta. This is to say angle CPB equals to theta according to our choice, and it equals to 60 degrees. This is to say theta equals to 60 degrees. This is the equation of the law of cosines that says that C square equals to A square plus B square minus 2 times A times B times cosine theta. Theta equals to 60 degrees according to our choice. So according to the law of cosines, in the right triangle CPB, the following equation is true. CB square equals to CP square plus PB square minus 2 times CP times PB times cosine 60 degrees. Repeat again, in this right triangle CPB, according to the law of cosines, the following equation is true. CB square equals to CP square plus PB square CB square equals to CP square plus PB square minus 2 times CP times PB times cosine 60 degrees. CB is the missing side, so we leave it as it is. So CB square equals to CP square. CP is 12, therefore CP square is 12 squared, that is 144 plus PB square. PB is 4, therefore PB square is 4 squared, that is 16. Minus 2 times CP is 12 times PB is 4 times cosine 60 degrees. Cosine 60 degrees equals to 1/2. So in total, if you found out that CB square equals to 144 plus 16 is 160. If we have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. After cancel 2, we left only with minus 12 times 4, that is minus 48. So in total, we found out that CB square equals to 160 minus 48 is 112. CB square equals to 112. Here we take a root out of this equation. We find again that CB equals to the square root of 112 units in its length. This is side CB. This is equals to the square root of 112 units. Its length. And CB square equals to 112. So in the next step, we define this angle CAB as alpha. And we will implement the law of cosines on this big triangle, triangles ABC. Angle theta equals to angle CAB, this angle that is alpha. So in the big triangle ABC, according to the law of cosines, the following equation is true. CB square equals to CA square plus AB square minus 2 times CA times AB times cosine alpha. And again, in this big triangle ABC, according to the law of cosines, the following equation is true. CB square equals to CA square plus AB square minus 2 times CA times AB times cosine alpha. We already found out that CB square equals to 112 and it is equals to CA square. CA square equals to 189. plus AB squared. AB in total equals to AP, that is 3, plus PB, that is 4. So in total AB equals to 3 plus 4, that is 7. Therefore AB squared equals to 7 squared, that is 49. That's 2 times CA equals to the square root of 189 units in its length, times AB, AB equals to 7, times cosine alpha. So in total we found out that Hundred 12 equals to 189 plus 49 minus 2 times square root of 189 times 7 times cosine alpha. So 112 equals to 189 plus 49 is 238. Here we have minus 2 times 7 is minus 14, so in total this expression equals to minus 14 times square root of 189 times cosine alpha. So here we will subtract 112 from this equation. After we subtracted 112, in this side of the equation we left with nothing, that is to say 0. While on the other side of the equation we have 238 minus 112 is 126 minus 14 times the square root of 189 times cosine alpha. So here we will add to this equation plus 14 times square root of 189 times cosine alpha, that is to say we will move this expression to the other side of the equation. And get that 14 times square root of 189 times cosine alpha equals to 126. So here we will divide this equation by 14. So here 14 will get cancelled. Inside of the equation you have only square root of 189 times cosine alpha. On the other side of the equation we have 126 over 14 is 9. So in total we found out that square root of 189 times cosine alpha equals to 9. Here we substitute 189 by 21 times 9. So 189 is 21 times 9 times cosine alpha equals to 9. We take 9 out of the root, so inside the root we left only with 21. The square root of 9 is 3, so this expression equals to 3 times square root of 21 times cosine alpha equals to 9. Here we divide this equation by 3. Here 3 will get cancelled and left inside of the equation only with square root of 21 times cosine alpha equals to 9 over 3 is 3. So total, if we found out that the square root of 21 times cosine alpha equals to 3. So here we divide this equation by square root of 21 and finally get that cosine alpha equals to 3 over square root of 21. So if we found out that cosine alpha equals to 3 over square root of 21. Here, TA is a abbreviation for trigonometric identity. We have the trigonometric identity that says that sinus square alpha plus cosine square alpha equals to 1. It's very easy to prove that this trigonometric identity is true, but we will not do it in this lecture. Here we will subtract cosine square alpha from this equation, from this trigonometric identity. And get that sinus square alpha equals to 1 minus cosine square alpha. So here we take a root out of this equation, and finally get that sinus alpha equals to the square root of 1 minus cosine square alpha. So found out that cosine alpha equals to 3 over square root of 21. We will square this equation and get that cosine square alpha equals to, we square the other side of this equation, this side. 3 over square root of 21 square equals to 3 square, that is 9, over square root of 21 square, that is 21. So in total we found out that cosine square alpha equals to 9 over 21. So now we can substitute cosine square alpha in this trigonometric identity by 9 over 21. And again, we have sinus alpha equals to the square root of 1 plus cosine square alpha. Cosine square alpha is 9 over 21. So sinus alpha equals to the square root. Here we have 1. We will multiply 1 by 21 and then we will divide it by 21 in order to become part of this number. 1 times 21 is 21 minus 9 over 21. We multiply 1 by 21 and then we divide it by 21, so we change nothing. It is allowable to multiply anything by 1. So here we have square root of 21 minus 9 is 12 over 21. Here we divide both the numerator and the denominator of this number by 3, and we get that 12 over 3 is 4, and 21 over 3 is 7. So in total, we found out that sinus alpha equals to the square root of 4 over 7. Here we take 4 out of the root. We take 4 out of the root. The square root of 4 is 2. So inside the root we left only with 7. So in total we found out that sinus alpha equals to 2 over square root of 7. Sinus alpha equals to 2 over square root of 7. we already found out that CB equals to the square root of 112 units in its length. In the next step, we will implement the law of sines on this big triangle ABC. So I repeat quickly on the law of sines. Actually, the law of sines has two versions. In the first version, we are talking about triangle ABC that could be any triangle. And here's side AB equals to 3 units in itself, side AC equals to B units in itself, side BC equals to A units in itself. This is again BAC. This equals to capital A degrees inside. This is again ACB. This equals to capital C degrees inside. This is again ABC. That is equal to capital B degrees inside. So in the first version, we have this triangle ABC without a circle. So in this triangle ABC, that could be any triangle. The following version is true: A over sinus A equals to B over sinus B equals to C over sinus C. This equation is true for any triangle. Triangle ABC could be any triangle. The second version of the law of cosines, we have this circle that blocks triangle ABC. That is to say, triangle ABC is described by this circle. The radius of this circle is R. So in the first version of the law of sines, this triangle ABC that is described by this circle, that is radius is R, the following equation is true: A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks the triangle. So we implement the law of sines in its full version. In this triangle ABC. First of all, triangle ABC is described by this circle. Why? Because of the fact that all the three vertices of triangle ABC lie in the circle. Therefore, triangle ABC is described by this circle. And therefore, we can implement the law of sines in its full version. So if we focus on the triangle ABC, according to the law of sines in its full version, the following equation is true: CB over sinus alpha equals to 2R. Again, CB over sinus alpha equals to 2R, and R is the radius of this circle that blocks triangle ABC. According to the law of sines, triangle ABC that is described by this circle, the following equation is true: CB over sinus alpha equals to 2R, and R is the radius of this circle that blocks triangle ABC, and R is also the radius of the circle that we are looking for. We are looking for the radius of this circle. So CB over sinus alpha equals to 2R. CB is square root of 112 over sinus alpha. Sinus alpha is 2 over square root of 7, and it equals to 2R. Here we substitute 112 by 16 times 7. It is the square root of 16 times 7 over 2 over square root of 7. It equals to 2R. Here we take 16 out of the root. The square root of 16 is 4, so inside the root we left only with 7. So this expression equals to 4 times root of 7 over 1 over 2 over root of 7 equals to 2r. Here we move root of 7 to the numerator and 2 to the denominator, and we get that 4 times root of 7 times root of 7 over 2 equals to 2r. 4 over 2 is 2, so this expression in total equals to 2 times root of 7 times root of 7 equals to 2r. Here we have 2 on both sides of this equation, so 2 will get cancelled. And the square root of 7 times root of 7 is 7. So 7 equals to r, or r equals to 7 units in its length. So the answer for this question is that the radius of this circle, that is the radius that we are looking for in this question, is equal to 7 units in its length. So we finished to answer the first question. In the next step I will present you the second question and solve the second question of this lecture. In the second question, our task is to find out the area of this semicircle APQB. So in the drawing we have semicircle APQB. This is the short line segment AC. This is equals to 7 units in itself. This is line segment PC. This is equals to 21 units in itself. This is line segment PQ. This is equals to 16 units in itself. This is angle CPB, that's equal to 90 degrees in size. Again, our task is to find out the area of this semicircle APQB. So first of all, we'll define the radius of this semicircle as x. AB is the diameter AB equals to 2x. What is the length of this line segment CB? From the drawing it is very easy to see that CB in total equals to AB minus AC. Right now, CB equals to AB minus AC. So CB equals to AB is 2x, it is the diameter of this semicircle, minus AC equals to 7 units in length, according to what is given in the question. So in total we should find out that CB equals to 2x minus 7 units in its length. Writing down CB equals to 2x minus 7 units in its length. In the next step, we will complete this semicircle to a circle. So I completed the semicircle to a circle. and we'll extend line segment PC by sideline until it touches the circle. We define the touching point of the extended line segment PC with this circle. This point is point M. Likewise, we define the length of this short line segment CM as A. So here we can implement rule 65 in our drawing. Please click here on rule 65. Rule 65 is true in any circle, so this circle could be any circle. According to rule 65, if chord AB intersects with chord CD at point O, then the following equation is true. AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So I can actually implement rule 65 in our drawing. Because in our drawing, we have chord AB that intersects with chord PM at point C. Again, chord AB intersects with chord PM at point C. So all the requirements for rule 65 are satisfied, and therefore can implement here rule 65. So it is known if you found out that in our original drawing, chord AB intersects with chord PM at point C. Chord AB intersects with chord PM at point C. Therefore, according to rule 65, the following equation is true. AC times CB equals to PC times CM. Again, AC times CB equals to PC times CM. So it is known. Repeat again. According to rule 65, this line, the following equation is true. AC times CB equals to PC times CM. This equation is the implementation of rule 65 in our drawing. AC is 7 times CB. CB is 2x pound 7, and it is equals to PC. PC is 21 times CM. CM equals to n in itself according to our definition. So in total we found out that 7 times 2x pound 7 equals to 21a. Here we will divide this equation by 7 and you get that here 7 will get cancelled, 7 will get cancelled, and we left only with 2x pound 7 equals to 21 over 7 is 3, so this expression in total equals to 3a. So in total we found out that 2x pound 7 equals to 3a. Here we add 7 to this equation and you get that 2x equals to 3a plus 7. In the next step, we will join points Q and M together by straight line. By joining points Q and M, we get that the green right line PQN. This is peripheral MPQ. Peripheral MPQ equals to 90 degrees in size, and it's subtend on this curve called QM. Therefore, whenever you have a peripheral that equals to 90 degrees in size, you can implement all 5 in the drawing. Repeat quickly on all 5. Only to all 5. Any peripheral angle is equal to 90 degrees inside must subtend on the diameter of the circle. In the drawing we have a circle. This is peripheral MAN. It's equal to 90 degrees inside, and therefore according to this rule 5, it must subtend on the diameter of the circle. And indeed peripheral MAN subtend on chord MN, that is the diameter of this circle. So according to rule 5, any peripheral angle that is equal to 90 degrees inside, any peripheral angle that is equal to 90 degrees inside must subtend on the diameter of the circle. We can definitely implement all 5 in our drawing. And put in our drawing. This is peripheral MPQ. It's equal to 90 degrees inside, and therefore according to all 5, it must subtend on the diameter of the circle. Peripheral MPQ subtend on chord MQ or QM. And therefore, according to all 5, chord QM must be the diameter of this circle. So until now, chord QM is the diameter of the circle according to all 5. The radius of this circle equals to x, and therefore the diameter QM must be equal to 2x. The next step, we will implement the Pythagoras theorem on this green triangle PQM. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So this green right triangle MPQ. Here by PT is the abbreviation for Pythagoras theorem. So in this green right triangle MPQ, according to the Pythagoras theorem, the following equation is true. QM squared, that is the square of the hypotenuse, equals to PQ squared plus PM squared. And again, according to the Pythagoras theorem, on this right triangle PQM, the following equation is true. QM squared, that is the square of the hypotenuse, equals to PQ squared plus PM squared. QM equals to 2x, therefore QM squared equals to 2x squared. And this equals to PQ squared. PQ is 16, therefore PQ squared is 16 squared, that is 256. Plus PM squared. PM is 21 plus 8, therefore PM squared is 21 plus 8 squared. So in total, we found out that 2x squared equals to 256 plus 21 plus 8 squared. We already found out that 2x equals to 3a plus 7. 2x equals to 3a plus 7. And therefore 2x squared equals to 3a plus 7 squared. And it's equals to 256 plus 21 plus 8 squared. So here we will square both sides of this equation. We will open both sides, the brackets of both sides of this equation. And get that 3a plus 7 squared equals to 3a squared, that is 9a squared, plus 7 squared, that is 49, plus 2 times 3a is 6a, and 6a times 7 is 42a. And it equals to 256 plus 21 plus a squared. 21 plus a squared equals to 21 squared, that is 441, plus a squared, plus 2 times 21, that is 42, times a is 42a. So here we have 42a on both sides of this equation, so 42a will get cancelled. After we cancel 42a, in this side of the equation we have to leave with 9a squared plus 49. While on the other side of the equation we have 256 plus 441 is 697 plus a squared. Here we subtract a squared from this equation. We get that 9a squared minus a squared is 8a squared plus 49 equals to 697. Here we subtract 49 from this equation. We get that 8a squared equals to 697 minus 49 is 648. So in total we should found out that 8a squared equals to 648. Here we divide this equation by 8 and get that a squared equals to 648 over 8 is 81. So in total we should find out that a squared equals to 81. Here we take a root out of this equation and finally get that a equals to the square root of 81, that is 9. A equals to 9 units in its name. This is line segment Cm is equals to A, is equals to 9 units in its name. Cm equals to 9. We already found out that 2x equals to 3a plus 7. I'll copy this equation here. X equals to 3a plus 7. X is the radius of the semicircle. So 2x equals to 3a. A is 9, so 3a is 3 times 9, that is 27 plus 7. 27 plus 7 is 34. So in total we found out that 2x equals to 34. Here we divide this equation by 2 and we get that x, the radius of the semicircle x equals to 34 over 2 is 17. So the radius of the semicircle x equals to 17 units in its turn. Our task is to find out the area of this semicircle. So what is the area of the semicircle? Actually, we know that the area of any semicircle equals to pi times the radius of the semicircle squared over 2. And therefore, the area of our semicircle must be equal to pi times the radius of the semicircle squared, this is x squared, over 2. So the area of our semicircle must be equal to pi x squared over 2. So it is pi over 2, and x is 17, therefore x squared is 17 squared. So it is pi over 2, 17 squared is 289. So in total we found out that the area of the semicircle, that is the area that we are looking for in this question, is equal to either 289 pi over 2 square units in size, or in terms of numbers, the area of this semicircle equals to 453.96 square units in its size. And again, we found out that the area of this semicircle, that is the area that we are looking for in this question, is equal to either 289 pi over 2 square units in size, or in terms of numbers, the area of this semicircle equals to 453.96 square units in its size. So we finished to answer the second question. The next step, answer of the lecture, we start with the repetition on the first question, then repeat on the solution of this second question. in the first question, our task was to find out the radius of this circle. So in the drawing we have a circle. This is line segment CP. This is equals to 12 units in itself. This is line segment AP. This is equals to 4 units in itself. This is line segment PB. This is equals to 4 units in itself. Again, our test. And this is again CPB. This is equals to 60 degrees in its size. Again, our test is to find out the radius of this circle. So first of all, it is given as a question that AB is a straight line. So if you focus on the upper side of the straight line AB at point P, the sum of the areas must be equal to 180 degrees according to rule 3. So we check as we have the upper side of the straight line AB at point P, we have this angle that is equal to 60 degrees in size, plus this missing angle. In total, the sum of those two areas must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 120 degrees in its size. The next step, we join points C and B together by straight line, and join points C and A together by straight line. By doing those constructions, we created 3 triangles. The first triangle is the green triangle ACP, the second triangle is this triangle CPB, and the third triangle is triangle ABC that consists of those 2 smaller triangles. So in the next step, we implemented the law of cosines on all those 3 triangles. Triangle APC, triangle CPB, the big triangle ABC. So, repeat quickly on the law of sines and the law of cosines. Implement the law of cosines on those 3 triangles. So, repeat quickly on the law of cosines. This is triangle ABC that could be a triangle. This is angle BAC. This is equal to 30 degrees in its size according to our definition. The length of side AB is A units, side AC equals to B units, side BC equals to 3 units in its length. So in this triangle ABC that could be any triangle, the following equation is to C square equals to A square plus B square minus 2 times A times B times cosine theta. Again, according to the law of cosines, in this triangle ABC that could be any triangle, the following equation is to C square equals to A square plus B square minus 2 times A times B times cosine theta. So in the first step, we implemented the law of cosines on this green triangle, triangle CAP. We choose angle theta as angle APC that is equal to 120 degrees in size. So according to the law of cosines, in this triangle APC, the following equation is to CA square equals to AP square plus PC square minus 2 times AP times PC times cosine 120 degrees. But again, this angle APC, according to the law of cosines, the following equation is to CA square equals to AP square plus PC square minus 2 times AP times PC times cosine 120 degrees. CA is the missing side, so we limit it, so it is CA square equals to AP square. AP is 3, therefore AP square is 3 squared, that is 9, plus PC square. PC is 12, therefore PC square is 12 squared, that is 144. So in total, we found out that CA square equals to 9 plus 144, minus 2 times AP times PC times cosine 120 degrees. Which is minus 2 times AP is 3, times PC is 12, times cosine 120 degrees. Cosine 120 degrees is equal to minus 1/2. So, minus 2 times AP times PC times cosine 120 degrees is equal to minus 2 times 3 times 12 times minus 1/2. This expression is a positive expression. Why? Because minus times minus is plus. We have 2 denominator, so 2 will get cancelled. And we have only 3 times 12, that is 36. So 9 plus 144 is 153, and this expression equals to 36. So in total, we found out that CA square equals to 153 plus 36, that is 189. CA square equals to 189. If we took out all those equations, and we found out that CA equals to the square root of 189 units in its length. this is the missing side C8 is equals to the square root of 189 units in its length. And CA square equals to 189. Likewise, we implemented the law of cosines on this right triangle, triangle CPB. We chose angle theta as this angle is equals to 60 degrees. So in this right triangle CPB, according to the law of cosines, the following equation is for CB square equals to CP square plus PB square minus 2 times CP times PB times cosine 60 degrees. Okay, again, this right triangle CPB, according to the law of cosines, the following equation is for CB square equals to CP square plus PB square minus 2 times CP times PB times cosine 60 degrees. CB is the missing side, so we leave this it is, and it is equals to CP square. CP is 12, therefore CP square is 12 squared, that is 144, plus PB square. PB is 4, therefore PB square is 4 squared, that is 16, minus 2 times CP is 12, times PB is 4, times cosine 60 degrees. Cosine 60 degrees is 1/2. So total, we should find out that CB square equals to 144 plus 16 plus 2 times 12 times 4 times 1/2. 144 plus 16 is 160. Here we have 2 in the numerator, 2 in the denominator, so 2 get cancelled, and we left only minus 12 times 4, that is minus 48. So in total CB square equals to 160 minus 48 is 112. CB square equals to 112. Here we took out of this equation, and we found out that CB equals to the square root of 112 units in its length. Repeat again. This is the missing side CB, that is equals to the square root of 112 units in its length, and CB square equals to 112. In the next step, we find this angle BAC is alpha, and we implemented the law of cosines on this big triangle, triangle ABC. Angle theta equals to angle BAC equals to alpha, according to our choice. So this triangle ABC, according to the law of cosines, the following equation is to CB square equals to CA square plus AB square minus 2 times CA times AB times cosine alpha. And again, this big triangle ABC, according to the law of cosines, the following equation is to CB square equals to CA square plus AB square minus 2 times CA times AB times cosine alpha. We already found out that CB square equals to 112, and it is equals to CA square. CA square equals to 189. Because again, CB square equals to 112, CA square equals to 189, plus AB square. AB in total equals to AP, that is 3, plus PB, that is 4. So total AB equals to 3 plus 4, that is 7. Therefore, AB square equals to 7 squared, that is 49. AB square equals to 49 times 2, minus 2 times CA. CA equals to the square of 189 units in its length, times CB times AB, that is 7, times cosine alpha. So minus 2 times CA times AB times cosine alpha equals to minus 2 times square root of 189 times 7 times cosine alpha. So in total, we found out that 112 equals to 189 plus 49 is 238. Here we have minus 2 times 7 is minus 14. So in total, this expression equals to minus 14 times square root of 189 times cosine alpha. So in total, we found out that 112 equals to 238 minus 14 times square root of 189 times cosine alpha. Here we subtracted 112 from this equation, so in this side of the equation we left with nothing, that is to say 0. While on the other side of the equation we have 238 minus 112 is 126 minus 14 times square root of 189 times cosine alpha. So here we added 14 times square root of 189 cosine alpha to this equation. And when we found out that square root of 14 times square root of 189 times cosine alpha equals to 126. Here we divided this equation by 14. So in this side of the equation, 14 gets cancelled, and we left only square root of 189 times cosine alpha. And on the other side of the equation, we have 126 over 14 is 9. So in total, we should find out that the square root of 189 times cosine alpha equals to 9. In the next step, we substitute 189 by 21 times 9. Okay, again, we substitute 189 by 21 times 9. So this 189, the square root of 189 is the square root of 21 times 9 times cosine alpha equals to 9. We took 9 out of the root, the square root of 9 is 3, so inside the root we left only with 21. So this expression equals to 3 times square root of 21 times cosine alpha equals to 9. Here we divided this equation by 3. So here 3 will get cancelled, and left only with square root of 21 times cosine alpha. 9 over 3 is 3. So in total, if we found out the square root of 21 times cosine alpha equals to 3. Here we divided this equation by square root of 21. So in this side of the equation we have cosine alpha equals to 3 over square root of 21. So cosine alpha equals to 3 over square root of 21. So again, cosine alpha equals to 3 over square root of 21. TA is the provision for trigonometric identity. We have the trigonometric identity that says that sin square alpha plus cosine square alpha equals to 1. Here we subtracted cosine square alpha from this trigonometric identity, and finally found out that sin square alpha equals to 1 minus cosine square alpha. Here we took out of this equation, and finally found out that sin alpha equals to the square root of 1 minus cosine square alpha. We have only found out that cosine alpha equals to 3 over square root of 21. So we scrap this equation. So in this side of the equation we have cosine square alpha. On the other side of the equation we scrap this expression also. 3 over square root of 21 squared equals to 3 squared, that is 9, over square root of 21 squared, that is 21. So in total we can find out that cosine square alpha equals to 9 over 21. Therefore we can substitute cosine square alpha in this trigonometric identity by 9 over 21. We did it, and we found out that sinus alpha equals to the square root of 1, and minus cosine square alpha is 9 over 21. So in total, we found out that sinus alpha equals to the square root of 1 minus 21. 1, the square root of 1 minus 9 over 21. Here we multiply 1 by 21 and then we divide it by 21 in order to come out of this number. So sinus alpha equals to 21 times 1 is 21 minus 9 over 21. 21 minus 9 is 12. Over 21 equals to sin alpha. So sin alpha equals to the square root of 12 over 21. Here we divided both the numerator and the denominator of this expression by 3. 12 over 3 is 4 and 21 over 3 is 7. So in total we should find out that sin alpha equals to the square root of 4 over 7. Here we took 4 out of the root. The square root of 4 is 2. Inside the root we left only with 7. So in total we should find out that sin alpha equals to 2 over square root of 7. And again, if you found out that sinus alpha equals to 2 over square root of 7, and we already found out that CB equals to the square root of 112 and sin itself. The next step, we implemented the law of sines in this big triangle ABC. Repeat on the law of sines. The law of sines is true in any triangle. This is triangle ABC that could be in a triangle. This is angle BAC. This is equal to capital A degrees in its size according to our definition. This is angle CB. This is equal to capital C degrees. And this is angle ABC. This is equal to capital B degrees according to our definition. Likewise, AB equals to C units in itself, AC equals to B units in itself, BC equals to A units in itself. Actually, the law of sines has two versions. The first version is that the area of triangle ABC without this circle, in this triangle ABC that could be any triangle without the circle, the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C. The full version is with this circle that blocks triangle ABC. That could be any triangle. According to the full version, this triangle ABC that is described by this circle, if we reduce out, the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R, and R is the radius of this circle that blocks triangle ABC. We implemented the law of sines in its full version. That is to say, with this circle that blocks triangle ABC. This is triangle ABC that is blocked by this circle. Why triangle ABC is described by this circle? Because why triangle ABC is described by this circle? Because of the fact that all the three vertices of triangle ABC lie in the circle itself. Therefore, triangle ABC is described by this circle. And therefore, we can implement the law of sines in its full version on this triangle ABC. According to the law of sines, in this triangle ABC, the following equation is 2. CB over sinus alpha equals to 2R, and R is the radius of this circle that blocks triangle ABC. And again, implemented the law of sines in this triangle ABC in its full version. That is to say, in triangle ABC, according to the law of sines in its full version, CB over sinus alpha equals to 2R, and R is the radius of this circle. That is the radius that we are looking for in this question. We already found out that CB equals to the square root of 112 and sinus alpha equals to 2 over square root of 7. Therefore, CB is square root of 112 over sinus alpha, that is 2 over square root of 7, equals to 2R. Here we substitute 112 by 16 times 7. So 16 times 7 over 1 over 2 over square root of 7 equals to 2R. Here we took 16 out of the root. The square root of 16 is 4, so inside the root we left only with 7. So this expression in total equals to 4 times square root of 7 over 2 over square root of 7 equals to 2R. Here we moved square root of 7 to the numerator and 2 to the denominator. We found out that 4 times square root of 7 times square root of 7 over 2 equals to 2R. 4 over 2 is 2, so in total this expression equals to 2 times square root of 7 times square root of 7 equals to 2R. We have 2 on both sides of this equation, so 2 we get cancelled, and we have to leave with square root of 7 times square root of 7, that is 7, equals 2R. So we found out that the radius of which we are looking for this question, that is the radius of this circle, is equal to 7 units in its length. So we finish to repeat on the first solution of the first question. In the next step, I repeat on the solution of the second question. In the second question, our task is to find out the of this semicircle APQB. So in the drawing, we have a semicircle. This is the short line segment AP. This is equals to 7 units in itself. This is line segment PC. This is equals to 21 units in itself. This is line segment PQ. This is equals to 16 units in itself. This is angle CPQ. That is the right angle. Again, our task was to find out the of this semicircle APQB. So, first of all, we define the radius of this semicircle as x. The radius of the semicircle is x, therefore the diameter AB is 2x. What is the length of this line segment CB? CB equals to AB minus AC. CB equals to AB, that is the diameter of this semicircle, that is 2x, minus AC, that is 7, according to what is given us in the question. So in total, if you found out that CB equals to 2x minus 7. In the next step, we completed this semicircle to a circle, and we extended line segment PC by straight line until it touches the circle. We define the touching point of the extended line segment PC with this circle. This point is point M. Likewise, we define the short line segment CM as A. In the next step, we implemented rule 65 in our drawing. Repeat quickly on rule 65. Rule 65 is true in any circle, so this circle could be any circle. So in any circle, if called a B intersection is called CD at point O, then the following equation is to AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. You can definitely implement rule 65 in our drawing. When put in our drawing, we have called AB that intersects with code PM at point C. Again, code AB intersects with code PM at point C. So in our drawing, code AB intersects with code p.m. at point C. So all the requirements for rule 65 are satisfied, and therefore can implement here rule 65. According to rule 65, the following equation is to AC times CB equals to PC times CM. Again, AC times CB equals to PC times CM. AC times CB equals to PC times CM. AC is 7, CB is 2x minus 7, and this equals to PC that is 21 times CM that is 8. So in total, if you found out that 7 times 2x minus 7 equals to 21a. Here we divide this equation by 7. Finally found out here 7 will get cancelled. The left only 2x minus 7 equals to 21 over 3, 7. 21, we divided this equation by 7, so 21 over 7 is 3. So this expression equals to 3a. So in total, if you found out that 2x minus 7 equals to 3a. Here we added 7 to this equation, and finally found out that 2x equals to 3a plus 7. In the next step, we join points Q and M together by side line. By joining points Q and M, we created the again right triangle QPM. This is again peripheral MPQ. Peripheral MPQ equals to 90 degrees inside, and it's subset of chord QM. Therefore, we can implement here rule 5, repeat click on rule 5. According to rule 5, any peripheral is equal to 90 degrees inside must subset of the diameter of the circle. In the normal circle, this is peripheral MAN. This is the right angle, is equal to 90 degrees inside. Therefore, according to rule 5, because of the fact that peripheral MAN is the right angle, it must subset of the diameter of the circle. And indeed, peripheral MAN subset of chord MN, that is the diameter of this circle. So according to rule 5, any peripheral that is equal to 90 degrees inside must subset of the diameter of the circle. You can definitely include rule 5 in our drawing. Because in our drawing, this is peripheral MPQ, that's equal to 90 degrees inside, and therefore according to rule 5, it must subset on the diameter of the circle. Peripheral MPQ subset on chord QM, and therefore chord QM must be the diameter of the circle according to rule 5. The radius of this circle is x, therefore the diameter QM is 2x. The next step we implemented the law of Pythagoras theorem on this green triangle MPQ. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So this great triangle MPQ, according to the Pythagoras theorem, QM squared, that is the square of the hypotenuse, equals to PQ squared plus PM squared. Repeat again, this great triangle PQM, according to the Pythagoras theorem, QM squared equals to PQ squared plus PM squared. QM is 2x, therefore QM squared is 2x squared equals to PQ squared. PQ is 16, therefore PQ squared is 16 squared, that is 256 plus PM squared. PM is 21 plus A, therefore PM squared is 21 plus A squared. So total, we found out that 2x squared equals to 256 plus 21 plus A squared. We already found out that 2x equals to 3a plus 7. We can substitute 2x by 3a plus 7. If 2x equals to 3a plus 7, this means that 2x squared equals to 3a plus 7 squared. And this equals to 256 plus 21 plus a squared. Here we open the brackets on both sides of this equation, and finally found out that 3a plus 7 squared equals to 3a squared, that is 9a squared, plus 7 squared, that is 49, plus 2 times 3a, that is 6a, times 7, 6a times 7 is 42a, equals to 256, plus 21 plus a squared. 21 plus a squared equals to 21 squared, that is 441, plus a squared, plus 2 times 21, this is 42, times a, plus 42a. Here we have 42a on both sides of this equation, so 42a will get cancelled. After we cancel 42a, this side of the equation we left only with 9a squared plus 49, while on the other side of the equation we have 256 plus 141 is 697 plus a squared. So if you found out that 9a squared plus 49 equals to 697 plus a squared. Here we subtract a squared from this equation, so 9a squared minus a squared is 8a squared plus 49 equals to 697. So 80 squared plus 49 equals to 697. Here we subtracted 49 from this equation, and I found out that 80 squared equals to 697 minus 49 is 648. So 80 squared equals to 648. Here we divided this equation by 8, and finally found out that a squared equals to 648 over 8 is 81. So a squared equals to 81. Here we took out of this equation, and we found out that a equals to the square root of 81, that is 9. So a cm is equal to a equals to 9 units in its length. We only found out that 2x equals to 3a plus 7. 2x equals to 3a plus 7. So 2x equals to 3a. A is 9, so 3a is 3 times 9, that is 27 plus 7. 27 plus 7 is 34. So 2x equals to 34. Here we divided this equation by 2, and we found out that x, that is the radius of the semicircle, equals to 34 over 2, 17 units in its length. The radius of x of this semicircle equals to 17 units in its length. Our test is to find out the area of this semicircle. Actually, we know that the area of any semicircle equals to pi times the radius of the semicircle squared over 2. Therefore, the area of our semicircle must be equal to pi times the radius of our semicircle squared over 2. The radius of our semicircle is x, therefore the radius squared is x squared over 2. So it is pi x squared over 2. The area of our semicircle must be equal to pi x squared over 2. X is 17, therefore x squared is 17 squared. So in total, the area of our semicircle must be equal to pi times 17 squared over 2. 17 squared is 289. Therefore, the area of our semicircle must be equal to 289 pi over 2 square units in size. In terms of numbers, the area of our semicircle must be equal to 453.96 square units in size. Repeat again. We should find out that the area that we're looking for in this equation, that is the area of this semicircle, equals to either 289 pi over 2 square units in size. In terms of numbers, the area of this semicircle equals to 453.96 square units in size. Okay, thank you very much.